Okay, stratified sampling, that's section 3.4. I'm not dealing with the earlier sections which only go up to grade C. You have links to the foundation videos on the foundation website. So stratified sampling is about taking the correct number for a sample from each grouping that you may want to survey or interview. If we go straight into question 2, you see what I mean by that. You can see there's different numbers in year 10 compared to 12 and different numbers in year 13 compared to the others. So if I wanted a sample of 50, for example, I couldn't very well take 12.5 students from each one. Obviously half a student doesn't work. But if there were 4 groups there and I was to take a stratified sample of just 40, it wouldn't be fair to take 10 from each, for the simple reason there's far more students in year 10 and 11 than there are in year 13, for example. So you must be able to do some simple mathematics that will enable you to get the correct number, the appropriate number of students from each group or stratum or class, so that they represent the full number of the entire population of that particular year group. So how many would be in each year group of a sample of 50 stratified by year group? Alright, so basically how many year 10 should I talk to, how many year 11s, etc. Well, if we look at the total, put here the total, 300 plus 300, you've got 600 plus 220 plus 180, I have 1,000 students. It's not difficult, is it? So I've got 1,000 students, and now I want to take 50 from this little group. Well, let's take a look. Starting with year 10, I require 300 over 1,000. It's that fraction of the sample of 50. Very easy, isn't it? 1, 2, 3, 1, 2, 3. Well, 3 5's 15. So I need 15 year 10 students, not 20. Not 12, that's the appropriate number for that year group. Now year 11 is going to be exactly the same because we have, just change that. Year 11 is going to be exactly the same because we have 300, same as in year 10. So I know the answer is going to be 15 straight away. For year 12, doing their A1s or some other course, we have this fraction of 50. So that's 220 over 1,000. That's the fraction of the 50 we require. So 220 divided by 1,000 multiplied by 50. I require just the 11 students from year 12, and finally from year 13 it's 180 over 1,000. It's that fraction of the 50 I need in my sample, and 180 divided by 1,000 multiplied by 50, I require 9 year 13s. Now, with a bit of luck, we got 30 plus 11, 41 plus 9 is 50. Yes, so I've calculated correctly. I've got my sample of 50, and please note it's different. I need 15 year 10s, 15 11s, I need 11 year 12s and 9 year 13s, and that's my stratified sample. How would these students be chosen? Well, let's take these 15, for example, these 15 year 10s. I've got 300 to choose from, so I've got to choose them randomly. So let's get a mark for writing the word random somewhere. Must be randomly selected. I've got to give an example here. If, for example, you gave each student a number from 1 to 300, you can assign each to those students a number, 1 to 300, and then use the random number selection on your calculator to select 15 students at random. So, for example, on your calculator, number 281 may show up randomly. So you choose student number 281, then you press the button again, you may get 94. So you choose the 94th student in your list of 300 year 10s, etc. So that these students need to be randomly selected. For example, use the random number generator on a calculator. Alright, that's the best way to do it, isn't it? And that's about it for that question. Next question. Right, question 3. It says the table shows the number of people employed in a department store. great big Debenhams or whatever. We have managers, salespeople, security and office staff. How many would be from each section for a sample of 40? Okay, so my first impression would be take 10 from each, that's 40. Well, if I take 10 managers, that's all the managers. If I take 10 from sales, there's 120 people who don't even get a look in. So we've got to do a random stratified selection. And so let's get the total first of all, so we know what to divide by. So I've got 10 plus 130 is 140, 25 security, and 35 office staff, 200 staff. So starting with the management, I require this fraction of 40. Is that alright? I'll do this with that calculator, I'm sure. Here we go. 1 times 4 is 4, divided by 2 is 2. So I'm required to interview or select 2 from management, and that's the appropriate size sample for that particular stratum. From the sales team, or those working behind checkouts or wherever, I've got 130 over 200, so it's a bigger fraction of sales staff, multiplied by 40. What fraction do I require? Let's just do this quickly. 130 divided by 200 multiplied by 40. I require 26 sales staff. Security, same way. 25 over 200 is that fraction of 40. Again, 40 is the sample size required. 25 over 200 multiplied by 40 gives me, got to interview or survey 5 security staff, and finally the office staff. We've got 35 over 200. It's that fraction of the 40 of the sample. Do the maths again. 35 over 200 multiplied by 40, and we shall be speaking to 7 of the office staff. Again, just to check, it's 28 plus that, 33, 40. Yep, absolutely correct. And it asks again, explain in detail how the office staff could then be chosen. Well, let's just go for the 2 managers, for example. We can again talk about assigning a number to each member of the management team, and then randomly selecting them using the random function on the calculator. So for example, if random number 8 comes up, then you choose the 8th member, whoever that is on your list, then that person gets interviewed. Then you press the button again, and if number 4 comes up, then you choose the 4th member, and these are the 2 people you select. Another way of doing it, of course, which isn't very technical, is that you write the 10 managers' names in a hat. You just pick out the first 2. Of course, if you have to write down 130 names for the sales staff, that's a lot of writing. It's much better to use the random function on the calculator. So if in doubt, if you're asked to do this, talk about the random function on a calculator. I think I've got time for one more question. Okay, same sort of thing. Number of students in each year of a large comprehensive school is shown below. So I've got from year 7s to 11s. I want a sample of 100 chosen from each group. Calculate the number of students from each year group to be taken. Well, let's just get the total first. Hopefully I've got time to finish this video. Right, 244 plus 221 plus 201 plus 195 in year 10 plus 182 gives us, that is a difficult number. Okay, so let's deal with it then. 1043. That's the population of the school. Make sure I've not miscalculated that. No, it's all good. Okay, so this is going to highlight a wonderful scenario which is good for teaching. Right, so here we go. That's the total. Now, I want 100 people. So one could say 20, 20, 20, 20, 20, 20 from each group. Of course, that's not good enough because we have different size year groups, and it would not be appropriate to take 20 from year 7 and 20 from year 11 because year 11s would be overrepresented and the year 7s would be underrepresented because there's far more of them. So we just do the same thing. So let's go with year 7 first. We have 244 over 1043. It's this fraction of the 100 that we want to survey. Grabbing the calculator, 244 divided by 1043 and then multiplied by 100. That gives me, now bear with me here, 23.4 Year 7 students. We'll play with the numbers in a minute. But leave it there for now. Year 8's 221 all over 1043. Multiply that by 100. There we go. 221 divided by 1043 times 100. We need to be talking to 21.2 of them. We'll leave the 0.2 for now. Year 9's 201 over 1043. Multiply that by 100. See how many year 9s we need to talk to. 201 divided by 1043. Multiply by 100. That's a sample of 19.3. Year 10's 195 over 1043 multiplied by 100. There we go. Let's just do the sum. 195 divided by 1043 multiplied by 100. That gives us a sample of 18.7. And we'll go for year 11's finally. That's going to be 182 1043 multiplied by 100, and that's going to give us, just do that now, 182 divided by 1043 multiplied by 100, and that's going to be 17.4. Now let's study these numbers carefully. Let's just try doing some rounding first of all. Let's go for this colour here. Now let's call that 23 in the first instance. We'll call that 21. We'll call that 19. We'll call that 19, and we'll call that 17. Now if this adds up to 100, we're happy. If not, then we have to decide which ones are going to increase or decrease to make the sample happen. Now it does insist on 100. We can't go for 101, even though the mathematic rounding may determine that that should be the case. 100 is 100. That's what we're going to go for. Let's just check these. We have 23 plus 21 plus 19 plus 19 plus 17 gives us 99. Okay, so we have a total of 99. We must find another student. 23, that shouldn't be rounded up, that shouldn't be rounded up, that shouldn't, that has been, that has not. Therefore we have a choice of rounding up either that one up to 18 to make our 100th student, or that one from year 7 to go for 24 students. So the choice is as follows. We can go 24 from year 7, 21, 19, 19, 17, or we can go 23, 21, 19, 19, or 18. So any one of these sets of answers would be fine. Put a little box around that. It's a really good question because it highlights the reality that whole number exact answers don't always come about, so you have to make a decision. Let's just refer back to that again. That could have been bumped up, as is the case here, or the 17.4 from year 11 could have been bumped up to 18. But obviously if you bump them both up, you go to a sample size of 101, and that's not permissible. And so what you have to do is make a decision, and both of these sets of data would be perfectly acceptable in an exam, as long as you can justify it and show clearly how you've got that. Don't give two sets of answers in an exam. Just go for one and stick with it, and make it very clear that you needed to get the sample size of 100.